So today our paper is why my code summarization model does not work. Code comment improvement with category prediction. So from this title, you can see that this paper focuses on the code comment generation task and using a new idea about how to categorize the comment. This paper is from TOSEM. The main other, I didn't search any information from the main other. And for the second other, Xia he is actually a visiting student from the David Low lab. So actually, he is a visiting student from the David Low's lab, and Xia and Hu Han is from the Monash University. They are the lecturer of the Monash University, and the final other is Li Shangping from is a professor from Zhejiang University. I guess he's maybe he's the supervisor of Chen Qiuyuan because they are all from Zhejiang University. Okay, so
I think it's now actually is going to leaving. Actually, he is leaving academia and join industry in Huawei, and he will be the director of a server lab in Huawei. He is called 2012 Huawei lab.
you
He
mean
will be
Xiangping?
no Xiaxing. Xiaxing is actually not a student anymore. He is now a professor, kind of a senior. A little bit. He is kind of a senior professor here.
Okay, what I searched is that he is a lecturer of Monash University in Australia.
Yeah, yeah. Now he is going to resign from Monash and join Huawei later.
Okay, so they are all they are all focused on the soft engineering and like soft analytic or something in soft engineering field. So first is the research background. Our soft engineering are very like to use the code commands to help our soft engineering task. And high quality descriptive document is very useful for create a robust code. And code summarization, which generate natural language description of source code, can assist developers to capture a high level overview of the whole code. For the task definition, first we have a formal definition of the code summarization. Code summarization is a task that aims to summarize the functionality of the source code. We formally describe the mapping as code to natural language, where code is the input of source code and the S is the output natural language summary. And here the paper has a new task. He defined a new task called command category prediction, which leverages the results of the command classification to build, classifies, and predict the command category given a piece of source code. So here it is just input the code and get the command category.
Then no need to write it because you already printed that.
So I because I want to, I have actually I'm not very I'm not very like understanding of this task because for each code I think we can have different type of command. So if a model just predict the command category, it is a bit strange from my understanding. Here I show you the here I show you the command categories. This paper have this paper gives us 6 category. And each category he used a word to represent this and express them. Yeah, because maybe I'm not very familiar with the software engineering, so I didn't I can't very see the difference between the different category. Besides, I think it's a bit strange to predict the comment category from code, because I think code can have different type of comment. That means one code can have a comment of what, and one code can have a comment of why. So it's very strange to predict the comment category from every code. Okay.
This paper has been, every paper has been gone through the peer review, and since they need to go through a peer review, they're supposed to be justified why they need to do these, right?
They just think if you classify the different comment, it will be better to generate different comment. But I think this is a bit strange. I will tell you more about later. Okay, so here is the data set. The others have 3 coder to manually label the validation data set. About 20,000 to 20,000 code snips. And the total data set can be split to train data set, validation data set, and test data set. And he just manually labeled the validation data set for different categories. Okay, so here there is 2 questions. The first question is how to classify different comment category. And the second question is how to generate comment. So follow this data set, he used the validation data set to train a model to classify the category of comment, and then use the training data set and the validation data set to train a generating model to generate the code comment, generate the code comment.
Can I go back to previous slide? I would like to go through the example of this category.
You mean this slide?
So what and why? Get a copy of that.
I think it's a very, I can't tell the difference very clearly. He just manually labels the data set with 3 coders. He hires 3 students to manually label the data set.
Okay, please go on. So anyway, so we would like to investigate their architecture.
Yeah, you
so
can.
Sometimes their arguments or justifications, I do agree with you that. So I don't see any point to further categorize the comments, but let's keep going on. So our focus is more like, so since we already have a deep submission zones, we would like to investigate as much architecture as possible so that I can catch the deadline. So keep going on. So if I find that some of the slides is not important, we can just skip it.
Okay. So you from the 3 code you can see that.
No worry. We can skip these slides now. So that's just more about data set. Yeah.
So now they just have a new observation because they train 6 different models on different categories. From the result, they can see that different category of comment have different performance. You can see from the experiment result, like for example, the code to sequence, it has a better performance on the category of how to use. And for the DeepCom model.
So the point is that they train a model with different categories. So for example, they separate the data set into six categories. And for each categories, they train a model to generate the comments.
No, he just he just tests on the validation data set and generates all the comment and calculate how much.
What's the difference? Your point and my questions. I'm saying that it split the data set into 6 categories, and for each category, and it used a model it trained a model on that categories and do the prediction.
Yes, I think the same. Yeah. Okay, so we can find that there exists a very big difference between each category, and in particular, there is no model that performs the best for Y and property commands. Besides, we observe that no model dominates in all command categories, which indicates that there is a potential to combine the advantages of different models. So this paper just focuses on how to combine different model to take advantage of these models.
Is there any explanations that why certain categories can have a better performance on certain model?
It just focus on the that's based on the observation. They think that if they select the model that performs the best for this category to generate commands, the result will be better. So I think it's a bit, trivial because
You could keep going. So
yeah.
anyway, they were this is a very two empiricals, and I think hard to hardly consider to make any conservative contributions. If they what they did is really just what they said. Keep going on.
Okay, so the up arrow just indicates the best model for the 6 type. So he just used these 3 approach in the following model, and if the command is in this category, like how to use category, then he used the code to sequence model to generate the command. Here is some of my thing. There's 2 methods. First, you just have a code, and then you generate the command 1 from the model 1 and the command 2 from model 2 and predict the class of the command. Then you choose the best command. Hello, any question? Okay, so in this way, you first generate all the command and then choose the best command because you know which model is best for the best class. Like if you like code to sequence is best for the Y command, then you predict the class of the command. Then it shows that it is a Y command. So you just choose the code to sequence.
Got it. So anyway, so it's more like a hybrid models, and for each model it will further predict classifications.
Yeah, but actually this paper just using this method, I think it's more strange because he just used code to predict the class of the command. He just input code.
The input is code. The input is code.
Predicts the class of the command, and then
for efficiency. It's for efficiency. That's for efficiency. That means if using the previous model, it means that, of course, I think maybe for the task prediction class based on comments maybe more accurate than prediction class is based on code. I suppose let's assume that they can well predict the class of comments based on code. And it just need to predict once, right? And it just need to generate the code. The generate comments for once. Yes. But for the first one, it needs to generate the comments for 6 times, and then you make the prediction for 6 times. I think that's more like for the efficiency.
Yeah, but for the second task, if you just generate one kind of comment, it's a bit strange because one kind of code can have different type of comment.
So it's more like how does their methodology believe that whether the category is exclusive. Overall, if the code is the comment category is exclusive, and I think the approach will be fine.
Okay.
Right.
So now here is model architecture. So I just explain to you. First, he have a data set and split to 3 training data set and validation data set and testing data set. and he just manually labels the validation data set into different categories, and then he have a labeled data to train a classified model. So now he have a new model to classify the comment category. This is a comment category prediction model.
It's both based on the code, right?
Yeah.
So the input is code, okay.
Yeah, that's based on the validation data that is code. And then he has another model. He just train on the code comment and just adjust on the validation data. Then they get a generating model. Then he combine the two model. The command is very easy. You just first predict the code category and select the best model for the category.
So in this work, they do not propose it. They didn't propose any new architecture.
Yeah. No,
so their contribution is just to combine those things.
No.
Okay. Let's keep going on. Let's finish the presentation. Maybe I can have a few comments here.
Yeah. No. So he tests takes five classifiers and to choose a best classifier to predict the code category. He finds that random forest the best performance. He just choose random forest as the code command category model. Okay, so here is the experiment result. From the experiment result, he shows that their combined model can achieve a better performance compared to the baseline model if you just use the basic model. Here, the combined model is add the information from the random forest. So he compared the different results and said that their combined model have a better performance. So I think it's very strange and trivial because he has a two process. First is train a generating model, and the second is train the random forest. It's the noise will accumulate in this process. I think it's better to train one model, like you have another neural network and to select the best performance, the best model. Then it will be much better from my perspective. Okay, and because he thinks that if this model just test on the testing data it's unfair because the distribution of this data is learned by the validation data set. So he just add an external data set to test the model, and he also shows that their combined model have the best performance. So he gave a case study to show why their model is best. Here is the example of Y comment. So this comment belong to the Y category, and the gold label is this determine if a chart sequence can be passed as a double, and this model can just very similar to the gold label, can generate the result very similar to the gold label. And these two models have a more complicated result. Actually, from natural language processing, I think these two comment is also very useful and valid comment. But he said these two are more complicated, so it's not used. The match will be bad if you use very complex sentence.
But right, if I'm doing the summarizations, I will not be choosing the third or fourth option because it's too complicated. Okay. Or the point is that there's no way to understand the different else details. And for this method, we just need to know this is just transform. But the point is that this approach or this work makes almost no technical contribution.
Yeah. No new model and no new architecture. They just combine the model.
Okay, please go on. I may have some few minor
Oh,
comments here.
no,
So
not.
today's presentation is kind of a tribute.
Yeah, it's just said that if you classify comments into 6 categories and use different model to generate different comments into different categories, it will be much better and have a very, state of art performance. But
Okay,
I
so I just have a few comments here. I agree with you that this approach kind of a tribute. But you know that sometimes the tribute method approach tends to be published. So once I just got a story, so long time ago, we went through journal papers, and I myself serve as a journal reviewer. So in the field of software engineering, there's 2 journals we consider as top. One is TSE, another is TOSEM. And the paper presented today is TOSEM. And TOSEM is actually a long time ago, TOSEM is considered as a very top journals, and very few researchers can publish on that journal. But with the time passing by, the journal of TOSEM gets less impact factor comparing to the other journal, because it accepts a very limited number of papers. It means that it will be very, if there's only a small circle of researchers care about the journal, even these journals is at top. So with the time passing by, the editors or the reviewers of that journal decide to enlarge the pool of their accepted paper. And I think this paper is one of sense to getting to, since the bar has been lowered. So this paper, just those kind of papers can get accepted. But overall, so this is the background of TOSEMs. But if we look at those journal paper, in the field of computer science, the journal paper actually is much easier to get accepted than the conference paper. So with the time passing by, so I suggest that in the future, we will not look too much into the journal paper, and the journal is more like, we use the journal is more like, say, if there's a conference paper, if we keep submitting the paper into a conference, but it keep getting rejected, and after we try 3 or 4 times, and finally we're going to give up. So in this case, we will submit the paper to the journal. And the major difference between journal and the paper, journal and the conference, is that in the conference, it's usually we have 1 or 2 rounds of rebuttal, and then the reviewer will decide whether your paper will be get accepted within 3 months, and the decision will be made. But for journal paper, it will have a long lifetime for the reviewing process. In journal, it will still have 3 reviewers. And in these 3 reviewers, and some of the reviewers will give you the minor revision, major revisions. And the major revisions is equivalent to some weak reject in the conference paper. So if in your conference paper, if you get 3 weak rejections, and your paper will definitely get rejected. But in journals, if you get 3 major revisions, you will still have a chance to revise your paper according all the comments given by the reviewer. Same sentiment again. So by this means, as long as you are not getting rejected at the first phase or at the first stage, you can always get a chance to keep revising your papers and finally get accepted. For these papers, I imagine that this reviewer will get some major revisions for the first rounds, and the process keep modifying and keep revising, and finally get accepted maybe for 1 or 2 years. So that might be the story of Joe. So in the future, I think in our paper submissions, we better time for the conference instead of for journal.
Okay.
Okay, let's talk more details about our individual meetings on Wednesday. Thanks to Yufan's presentation, and let's call it a day today. And Xiaoling, do you have